Hello, welcome 21 participants at Podim. Hello from Carinthia, hello from Klagenfurt. My name is Philipp. I work for BABEG, and we have here this nice panel on building up ecosystems. Oh, I think this is already, the table is shaking. I need to get away from the table, which will be a hard task. So we have prepared some nice, interesting topics for you. They are over here at happening over in Carinthia. We have lots of exciting research institutions here, and we prepared some nice program for the next 45 minutes for you. To give you a short overview on that one, we will had three research institutions portrayed in a nice video for you, exclusively for the Podim conference, so that you can have insight and the people talking about their research and about their organization. So we will talk about, in the first row, about Saal, Silicon Austria Labs, which is a research institute with about in Carinthia and in other states in Austria as well. But in Carinthia, they emphasize on sensors and their emphasis on power electronics. After that, we will have an insight on the Joanneum Research Robotics Institute, also based here in Klagenfurt, from the huge and well-known Joanneum research. And finally, but at least, we have a special view inside to Lakeside Labs, which is a research office close to University Klagenfurt, doing research on self-organizing network systems, and they work a lot on drones technologies these days. What's that? Okay, I have a counterpart here. This is Yanni, my nice colleague who helps me out. And when I'm sometimes look that way, then I look over to Yanni, and he gives me some kind of advice.
I just hello everybody. I just wanted to tell you that two of those research institutions are based in the Lakeside Park behind us,
which is absolutely true. So let's have a few words about Carinthia in common. It's the south most federal province of Austria, and it brings together some kind of technical expertise and bringing together some advanced technology, and have also an attractive mix of industries which are embedded in a highly innovative environment. This is not only research institutes or universities or University of Applied Science. This is also, Carinthia has demonstrated its powerful development in technology, in innovation and research over the past decade. Some research institutions are core really in the field where the Carinthian industry is happening, and this is, brings together a very close, long strategic relationships of industry and research working together. The research quota of Carinthia with 3.15% is very high, and it's currently the fourth ranks in the state of Austria. But at the same time, as said, it's an extraordinary high share with the research-based industries with about 75%. So that's enough of facts and figures. To give you names, to name a few, we have some leading global enterprises that Carinthian technologies like LAM Research, CAPS Trafficom, Marlow, and they are, of course, the international champions in Carinthia's technology expertise. But in the last few years, around that, let's say, field of connection between research and industry, there's a lot of companies expanding their local research and build up some development centers. As mentioned, Infineon Technologies made a huge invest into Carinthia. Also, the new founded Saal Silicon Austria Labs, which we will see in a video soon, and also Fraunhofer settled down in Carinthia. But it's not just that all the research institutes and the industry, it's also about the very good academic education, which is possible here in Carinthia from the Alpen-Adria Universität, where they have a very active technical department and a lot of institutes which are very well known for a short time. And we have the very engaged University of Applied Science and lots of other education institutes as well. These research-intensive small and medium enterprises are also very growing in that field, which is very nice, and we give some future improvement in the fields of electronic-based systems, microelectronic, also mechatronic and medical technology. So enough said about Carinthia. Can someone please add us a comment in the chat? I want to see if we're really live and if there are really people out there. Is there anyone typing? So just say hi or something, and we're not alone here. Can you do me that favor? All right. Hello, Milan. Great to have you here. Hey, this is my colleague on the side. Hi from Graz. Cool. Hello, everyone. Greetings from Infineon. Raphael. Nice to meet you. Okay, great. So we have some known people and we have some people from abroad, which is very great. And greetings from Bulgaria. Hi, Jordan. Welcome here. So let's see. To tell you just about these wonderful research thingies. As mentioned before, we made some small videos. They are about 8 to 10 minutes long, and they give you an insight. And I want to first start with Saal, which is a research institute working on technology that will influence very strong on future product and processes in electronic-based systems field. And they are a key research institute to key enabling technologies. And I made this video and talked to Christina, which is head of research facility here in Carinthia, and she was very open also for startups and also for startup ideas. So if you maybe have a technical question in the key enabling technologies, so it's very easy to just drop around and give her a message. But you will see in the video, I'm going to try to share the other screen now. The video screen seems to be here and to be working, hopefully. So now you should see that screen. No, it's not. Okay. Where is that screen? Is it as now you see the screen? I hope so. Okay. All right. Ja, da muss ich aber erstmal auf das Fenster gehen. Aha. Okay, video starting now.
They want to solve. And we are really starting from a stability and trying to find what is the best technology, what are the possibilities we have. We are not always investing in sensors, because if you're a company that are not specialized on building sensors, you will not use the sensor. But you want to use the sensor. You want to use the sensor of your application. And this is, I think, the starting point of many corporations here. I think it's very challenging, but I think it's most efficient if you always combine huge enterprises together with SMEs, because they work differently, they have a different attitude, they start to think differently. And bringing them together in a consortium is really a value, not only for the small and medium-sized enterprise, but also for the big player on the market. SAL is a non-university research The focus of our research is in electronic-based systems and along the value chain. We are starting from sensor systems, power systems, and RF as a communication system, bringing everything together with smart system integration technology. And then something that is really necessary for the future of electronics-based system is intelligence. And so the last division is really focusing upon embedded intelligence. This altogether will be the electronic-based system of the future. We are very focused on the different locations we have. The headquarters is in Schranz, and here in Philipp, where I am based, we are focusing on sensor system, especially on microsystem technology with a huge clean room facility and system integration technology. And we have also a part of power electronics here in Philipp. And in Graz, we have power electronics and embedded intelligence, and in Linz, the focus will be on RF systems. The great challenges for Europe in the future will be that research, production, and everything remains in Europe. We always have the problem, electronic-based system, what is the goal of it? We always search for new functionalities. We want to have new functionality for the users, for the companies, for the industry, and we want to develop this. And this always is in between the idea, bringing the research from university to industry to really make innovation out of it. And the great challenges can be seen in manufacturing as well as bringing together the component system integration technology, combining hardware and software tools, and then also in the end testing reliability and bringing this product in a very short time to market. The overall topic is electronic-based systems, but electronic-based system can be a lot. So every division, every research division needs to focus on certain topics. But I just want to give you an example. We have now filed the project application for a project where we really need use sensors, bringing in communication, bringing in intelligence, and putting everything together with system integration technology. And this system is really on a very tight, specialized way that we really can combine it. And there will be this huge project in this field. For sure, if CTR or now SAL will do all kinds of sensors, there will be no focus in it. So this field alone is already too much. And so all division will specialize, but will try to really close the value chain and really create more impact for the different industries. I'm quite lucky in this situation. I like this question because we have many projects here, especially in Philipp, ongoing, where we work on. One of my favorite projects, as I'm a physicist and I really enjoy the topic of new topics like quantum sensing, for example, we have started one project. This is called Q-Sense for Life with different industry partners like Infineon and Philips, and together with the University of Vienna, working on really developing quantum sensors for the future. If you imagine sensing technology, you will get to the borders of sensors. You cannot make them smaller, you cannot make them any more accurate and not safer or secure. And quantum technology will give the possibility to go in this direction. And we are far away from the market. It will take us 10 years to go until we really place such quantum sensors in future applications. But still, I think it is a very interesting, and you can really do there something very, very impressive for science, and therefore we really enjoy to work in this field. I'm not in the position to talk about quantum computing, I have to admit. For us, quantum computing is quite far away. We are focusing really on the sensor topic. Yes, it is far away, but it will be the next step. There I'm convinced, because if you really want to overcome accuracy topics, there will be only this chance. And if we think about topics like that in our kitchen appliances, we will have the chance to measure immediately during cooking the vitamins, how many sugar is inside, really in the floor of a pan, for example. This will be really something our future, because this will really have a huge impact to the customer in there. But not next year. We have a big advantage here in Carinthia, I would say, as I'm also from Carinthia, is that we combine a very interesting facility here, an interesting lab structure, huge possibility for our researcher. On one hand, on the other, we have the opportunity to grow in a network between Graz and Linz with a close connection to the universities there. And on the other side, we have really, just look outside, we have the mountains, we have the lakes. And so it's always for HR topics a combination of both. To get the best scientific people or the scientists here, it's always a combination that we are needing. With really the cultural differences, which are huge impact. And sometimes in meeting I smile a little bit because the nationality brings in so much different aspects. And I have a new Chinese colleague. In the first meeting he told me, this we are doing today, this are we doing in the project, and this we will do in the next project. In the kickoff meeting of the first meeting with the company partners at the start of the project. And I thought, this is really something that we will not make from our side. And I think we are really making a lot of profit with this. On the other side, we have to combine the nationalities. And I sometimes on Friday I laugh, it's a German-speaking day. And this is always a lot of fun. We have the whiteboard there and really try that all our people here learn a little bit of German. It's nothing about that we want to talk in the meeting in German. This is not necessary for us. But really living and being integrated in a surrounding, they need a little bit German. Later, if the kids go to kindergarten, and in the kindergarten nobody will speak English with them. Come early enough, especially if you have a good idea. There are many possibilities for small companies to get support there. There are programs like InnoCheck Disability, where you can start with a little amount of money to do some research. And if you have just a question, pass by. I would say a little bit more time for me personally to do research, because I'm at the moment really fighting for every hour that I'm doing research. As in management, there are many things to do, especially I think about the new building that is coming here in the High Technology Park in Philipp. And we are aiming for a new clean room of 1,000 square meters. There are big challenges in the moment. And I sometimes really want a little bit back to do a little bit more research, focus on the topics I really enjoy doing. And for all of us, I think less administrative work and more research is the things we all want to have.
Okay, this was the video of Zal. Is there anybody in the audience who wants to know more and have maybe questions on that one? Hello, anybody there? Okay, how was the tone? Melanie, Michael, Claudia, could you please turn on the video so it's much more nicer when we see that there's a panel on stage, so to say. Oh, there's Melanie coming. Hi.
Hello.
So in the audience, which is increasingly growing, are there any questions about Zal? You have heard about the research they do and the field they do. I bet these are some future topics and some key enabling technology research on that one. To sum this up, they have a division for sensor systems, for RF systems, power electronic and system integration. They have facilities in Graz, where's the headquarters. They have facilities in Villach and Linz. Unfortunately, no one of Saal joined us today here on the panel. So if there is no questions I can ask from the audience, this is your last chance to call and raise the hand. Okay, turn on the page. I hope this gives you a short overview about the research in Saal. So next ahead, Michael Hofbaur from Robotics Institute and Mechatronics from Joanneum Research. They do a lot of interdisciplinary forms on robotics, and they work on a lot of aspects which will, contribute to our business and to our everyday life, mainly in the topic of classical industrial production. Michael, hi. To sum this up, is there any relation to Saal so far? Did you cooperate in the past, or are you planning to do in the future?
Do that online, right? I have to apologize for the building noise here, so another complication. Yes, we're in close contact with each other, in particular on the sensor platform and sensor technology. That's things that touch our robot systems quite well, and that's what we're currently thinking of getting projects online.
Great. So we have also some nice movie, and please see the movie we made with Michael Hofbaur and about his institute to give us a short insight into his research. And then please prepare your questions. This is a great chance to talk to the people who have really the research here in Carinthia in their hands. I try to give my screen again. Okay, where is this? These are a lot of windows open. It's that one.
Research wish for free. I want to build a robot system that understands what it's doing, right? And can act in a responsible way so we can deal with those systems as partners in the future world. I think robotics has a lot of application. But it's a complex technology that needs some support for bringing it into the field. And here at Joanneum, we're supporting industry by getting robots in, using them as power tools, and also for certification. I think we have a lot of connections with the other institutes, for example, Hirschl. But we also stand by ourselves, focusing very much on robot system core technology. They're very challenging, very sexy, but also very difficult to deal with, and very complex. So it's a very complex system integration task that you have to deal with. And we're still not there that one can use them as power tools. There's a lot of research needed. Of course, the classic robot applications are very established, but we're now moving into new domains. Domains where robots and humans work side by side, and robots become power tools of workers in manufacturing. There are certain aspects that seem very trivial, but for example, that a robot recognizes that a human stands in front of you and recognizes that very accurately and very reliably. And that's key, which goes into, it's not just vision, but also understanding what the robot sees and act accordingly. I think this, in that perspective, using AI, using modern planning algorithms, control algorithms to really have flexible application of the robot. Surely challenging, but it has also a lot of potential because it's our flexibility that we have, a flexibility that a robot system currently doesn't have. And if the robot works together with a human, it has to adapt to that unstructured environment that we're so good in dealing with. And that's the critical part, not just seeing, understanding, acting responsible way, something we humans do. We also want robots to do that. Here I have to ask you again, do you mean security or safety? Because both aspects are extremely important. So it's on the one side physical safety. I mean, robots are powerful machines. Robots are machines and they're dangerous. And we're not used to work with them. So we're not familiar with their actions, and this can pose dangers. So the regulation is very strict for our safety, right? Take, for example, crash tests. Crash tests are very common in automotive engineering, and they will become more common here in robot systems as well. And in fact, our system, our institute is the first and only accredited test center for robot crash tests here in Europe right now. And that's a big asset to bring robots into the field, to support industry, to really adopt these new technologies. On the other hand, if you talk about security, we have the situation that under those Industry 4.0 aspect, we want the robots to be networked, we want them in the net, but then they experience the dangers of the net. And the danger becomes even more critical than in classical computer systems, because the danger can impose physical danger. The robot can hit you if the safety system is tempered through some intrusion. So that's the key. You have to consider both, and you have to deal with both. And we deal with, for example, security by penetration testing robot systems, and, which is also very important, raise awareness that this is a critical issue that industry has to take care of. So we have, to my knowledge, there's only one thing like the equivalent of a virus scanner for robot systems. It's something completely common in robot and in computer science, in computers, but it has to be more common in robot systems as well. I think the business market will use them as machines, as flexible machines, adopt them to perform things that were unthinkable right now. So if you think about digitalization, a lot of the digital market works because it's software, right? But there is so much potential where we need the physical interaction with the real world, and that's where robots can come into the game. So it depends what you're looking for. So if you're thinking of using robots for an innovative idea or production or whatever, we can support you to deal with one hurdle, that is the engineering hurdle. Normally it takes a lot of engineering work to get started with your idea. Here we can try it. We have something like a human-robot co-working space where you can try things out, fail fast, and succeed with what you want to get. On the other hand, if you provide robot system technology, technologies, yes, you're very welcome to join the lab as well. Come here. We can maybe complement what you're working on, support you with our systems, robot systems, measurement systems, infrastructure to really get started. I think the environment supports us quite well. So we have on the one side the business support, on the other side the academic support from the nearby university, and the nearby regions, right? So it's very close to Slovenia, it's very close to Italy. It's also not too far from Germany. I think it's right in the center to be quite productive.
Okay. We can just beenden. Oh. Good. Here we are again. Mr. Hofbaur, so as mentioned in the video, there's some challenges in the human robot interaction. So please give us a more emphasis. How did you manage to solve those challenges? What are the steps to give a good interaction between humans and robots?
I think the application of the robots have to be thought differently. It's really a lot about human safety in the environment, and one problem that we mostly see is that the capability of the machines is strongly, you think they are far more capable of what they can really do. They are very hard to perceive their environment, as mentioned. It has to be done at a very high safety and security level, and all those things together make it really a tricky thing to do.
So when I want to work, for example, so what would be a good background to be an expert in your team?
It's very wide. So my team starts from mechanical engineers up to computer scientists, mathematicians, almost every branch of technology that you find in this mechatronic information technology umbrella. So it's very open.
Mm-hmm. So what is the urgent needs? What are you looking for most at the moment as employees? It's a very wide field.
Classic robot technology is surely something that is very highly sought for. Safety, security topics. I'm very open.
So, is there any more questions from the audience? So this would now a good time to drop a line. So the team background we mentioned already. Alenka, do you want to make an application?
Some of our products. So the robots that we work on are mostly focusing on robots that are applied in production. Products in that sense, we're trying to implement things and build novel machines for our customers in industry. But in terms of novel technology, we're, for example, working on a robot skin that can sense. It's like an aura around of the robot that can sense the environment and work with it. And topics that we're currently focusing a lot on is also what does 5G offer for robot systems in the future.
Okay. So Alenka wrote she's a risk consulting business from insurance broker. This brings me up to a question which may be interesting. So how is it with insurance? Is this really a topic when you're developing technologies? I mean, in the video you talk about safety and security. So for safety reasons, is there maybe kind of kind of a rate you get for better development, like special for space technology? There's always a special product line. Is there in robotics also a special safety product line, for example, which are good in insurance rates?
I think we can be your insurance, right? So as mentioned in the video, we have a test center. And when you want to bring a robot on the market, it has to comply the rules that are written down in the machinery directive. So they have to be safe. And we can provide you the assurance that those robot systems are safe on a very high quality standard that will hold in court if somebody gets hurt.
Let's put a final question in the spotlight again. You are a certified testing center for robotics. So if I am a startup and have some kind of robot technologies, I can come over to you and you can do a reliable test on law standards?
We can do reliable tests. And the other most important thing probably is we can guide you towards what you really have to think of if you want to bring your robot from a lab environment into the real world.
Great. If there is no more question for Michael Hofbaur from your new research and robotics.
There's one more there. So the customers are mostly companies in production, but also like system integrators that build robot systems for industrial use. So it's twofold, more or less along the almost whole value chain of robotics.
Great. One final question. There's this 5G playground at the Lakeside Park, and I know that Lakeside Labs is also doing cooperation on this 5G playground. So you have plans to use these 5G technology for robotics in future?
Is it me or Claudia who you're asking?
It's you, and then I switch over to Claudia. This is the Überleitung, you know?
Yeah. So of course we're using those technologies, and we actually share a space where we can bring together our systems and do collaborative research on 5G. So we don't have to hop between 5G providers. We have them condensed form here for our research purposes.
Great. Thank you for taking time and having the questions. Now I'll switch over to Claudia. Claudia, as a research institute on self-organizing network systems, 5G is a game changer, right?
Yeah, right now it's like everybody is talking about 5G and already starting with 6G. And we are glad that we are here in the Lakeside Park. The picture that you have right behind you, you can see the buildings where one of them we are in the other one, Michael Hofbaur is in there. So we have the great opportunity that we have a 5G playground, which gives us the possibility to work with it with drones, do swarms of drones, use them for robots, use them for ground robots, for whatever, and try to be really on the front end in the research for 5G and the applications for it especially. And it gives the possibility for companies and startups to try it and try their new research and new products already in a new environment, in the 5G environment.
Yeah. But Lakeside Labs is of course more than a 5G application research. So a hub for science and innovation on self-organizing systems, self-organizing network systems, to be correct. These are tools for network of the future, right?
Melanie,
So,
you want to say?
Yeah, Melanie.
Yeah, so I just wanted to give the floor to you, Claudia, because you guys are going to hear me now the next 10 minutes. So, Yeah, it is a great opportunity for us to further. In self-organizing network systems, different devices work together. They cooperate. They need to exchange data, and therefore 5G, of course, is a good opportunity to handle all these latencies that should be rather low, but also the high throughput that could come with it.
Okay, so and these self-organizing network systems are in our future world standard, would you say?
I would say yes. So due to this increasing complexity and the increasing number of them that we are using already nowadays, it's getting more and more critical to manage them, to coordinate them, and there could be even more potential in collaboration among them.
Okay. So I would say let's watch the nice video we made about Lakeside Labs, and then we hear you again and see you again.
Systems face different advantages. One advantage is adaptivity, because due to the local rules, the system can easily adapt to all upcoming issues, for example, related to a dynamic change of the environment. Another advantage is robustness. So if a device fails or is not able to perform its action, the whole swarm, as we call it, can still fulfill the mission. Another advantage is scalability. So as each agent performs local rules, it is there is no matter whether we have 100,000 or even more agents in the system. This is important because we have a lot of devices that are interconnected with each other, and it's quite hard to manage them from a central point of view. Having self-organization on the other, we apply local rules, they have local interactions, and the system is able to be coordinated and managed. Yes, so swarms are nature-inspired algorithms. So this means that we apply different behaviors from, for example, ant foraging, flocking of birds, or, for example, even swarms of bees, so in bee colonies. They use different behaviors, use these local rules without central control, and still a global behavior emerges. In drone swarms, especially in search and rescue, the drones are able to perform their operation in an autonomous way. So this means we do not need an operator for each and every drone, and still this mission can be fulfilled. Other applications that we work on are, for example, can be found, for example, in Industry 4.0, where we control large production plants using local swarm intelligent rules, so that there can also emerge this optimization of the fab. Another application can be found in logistics, where ground rovers work cooperatively in a swarm. The biggest challenge is to produce real autonomy. So engineering swarm intelligence algorithms for any kind of cyber-physical system is quite challenging because we still face boundaries related, of course, to security and to safety issues. We are cooperating with different research institutions, other industry partners to address this challenge. Our projects on European level, but also on national level, are quite industry driven. So this means we incorporate the requirements for swarm engineering in our projects, and also work quite closely on industrial driven needs and also limits. So there are multiple ways to do so. The easiest way is to just contact us, and we sit together, work on different ideas, check where the requirements are, what could be even improved using self-organization, and this typically leads them to a joint project. In general, swarm intelligence is a subfield of artificial intelligence. And this is something that will come up, of course, in future. So this high connectivity and also this introduced high complexity then will bring up even more ideas, more possibilities to manage these complicated structures in future. A day-by-day solution would bring up, for example, the optimization of industrial plants. This would again reduce the overall cost of the optimization and therefore also the overall cost of our products. Not just electronics that we consider, we also have a lot of interdisciplinary projects where we work together with people from economy on the one, but also with psychologists, so that we can check whether self-organization could be also a principle, how humans work together, how they work in a team, and could even perform better. So we at Lakeside Labs have a quite active startup culture. So this means that different outputs from different projects that are used and transformed into business ideas. And of course, we at Lakeside Labs also support them throughout their lifetime. Yes, they do. So we at Lakeside Labs have different viewpoints. So on the one hand, from research, from industry, and of course, these different viewpoints that bring together also new research activities. So if I could get a wish for free, I would be really happy of having a big, a big house where we could, that is solely dedicated to swarm intelligence. Not only basic research, but also as we do industry-driven research directly connected with the possibility that we can also test them online. Because this is quite difficult, especially you could imagine for production manufacturers, but also for swarms of drones. So for everything, you need nowadays a lot of authorities handling these experiments.
So hello again.
Okay.
Yeah, thank you for helping us out on the video, and I hope the visitors. Oh, it's still running.
I'm still talking.
It's still running.
Right.
Okay, so I stopped it. Thank you, Claudia. There were some questions during the chat. Would a planned inspection with drones possible? Yeah.
Yep.
You think about?
Yes, I did. I'm sorry. Well, yeah, you can do any kind of inspection with drones. I mean, most of the times right now, people are doing it with a single drone and they're doing plant inspection or wire inspection. What we are doing is we are focusing on using a swarm of drones. So, for example, if you have a big section there, you have to search a person, for example, and it's crucial in time. You send out 5, 10, 20 drones, and they are looking for a special object, for example. They would search this object, communicate with each other, and tell you immediately where it is and tell you the location of the person. Another thing would be if you do inspection or like security, for security reasons, that you want like night shifts, the drone go by themselves autonomously, and to have more of them, not only one, but to be on the different sections on your premises. So that would be one of the possibilities that we would do, or one of the scenarios. The distance that you can fly with the drone depends on the drone. So we are not doing the drone themselves. We are doing the software for the navigation, for the communication of the drones with each other. It's not that we are doing the drones themselves. So it depends on the model that you get, on the length of the echo that you can use. And then it depends also if you, for example, search for a person, if it goes in the height, like you go steep in the mountain, then probably the distance would be shorter. But we were discussing with different partners, for example, for inspection, for wires, for bridges, for whatever. And it always depends on what you want to do. So I hope that answers your question, Alenka. And yes, there was this one company we got in touch today as well, and they're like the startup that's focusing on that right now. So
yeah, that underlines the startup culture you had, so you know what's on. But Alenka asked, are these drones guided? If I get you right, Claudia, the drones are not guided. They guide themselves as a self-organizing system, right?
Exactly. I mean, it's not that you have to stand there and you have to go with your remote control and you have to tell them where to go. I mean, you just tell them the area where they have to fly and what kind of missions they have to complete. And then they're going by themselves and they're coordinating themselves. They're communicating with each other. If one of them is short of power and like drops out or has to land, then the others take over their responsibilities. So that's the difference of a swarm to a single drone.
Great. So to me, to sum this all up, this looks very neat in Carinthia. So we have institutes for electronic-based systems which provide with batteries, with basic electronic, with sensors. We have a strong cooperation between those big research institutes here in Carinthia. We have the robotics with all the challenges, and we have, of course, swarms of drones at Lakeside Labs. So how cool is that? So please feel free to visit the websites of the research institutions to get in a more deep dive if you're in a related topic. So now you have the faces to the company, and I bet it's much easier to drop a line of an email and ask a question, maybe for support or maybe for cooperation. We're very open here. And so if there's no more question popping up, I would close this panel and wish you a great afternoon. So have greetings, all participants, and thank you, Melanie, Claudia, and Michael for joining us here on this plot.
Thank you as well, and please feel free to just contact us. Bye.
Thank you. Bye.
Bye.
And Alenka, if you still hear me, yes, there is a risk with the software. I mean, right now we are in different projects, also with the government, for example, because swarms themselves, they can be a risk for drones because every single subject is fulfilling their mission. So that's one of the risks, but we are totally aware of that. And then drones can be jammed. Everybody knows about that. And yeah, well, there are a lot of risks, but these are the things that we are also doing the research on, and we have to keep them in mind. But every technology that you use always has a risk with it as well.
So there's another question popping up. Now the question's coming. It's a good trick to say goodbye, and then they all raise their questions. So do you fear that drones can use as a weapon, Claudia?
Well, yes, sure. I mean, we know it from some areas, especially where we have war, that drones are used as weapons. I mean, we are totally out of that. I mean, we are not doing research on that at all. I mean, even handies in the past were used in military and for military uses. Drones for us is something that we want to use for safety, for search and rescue, for example, for searching people after an earthquake, for setting up relays to get communication to areas where you don't have any networks anymore. And so for us, it's something totally different. But yes, with everything, I mean, even with a ground robot or another robot or even cars, you can make weapons. So we can never exclude that somebody uses it for it.
Of course, that's always.
The small thing that I'd like to add here is that the drones, of course, are a big and a good use case also to showcase different things. But we also work with other use cases for example, in production with ground robots, as you already said, Claudia. So there are many different things where you can see and have devices that can be intelligent also as a collective.
Mm-hmm.
Great. Thank you for staying this few minutes. We can leave this open until tomorrow, so you can drop the questions. Claudia and Melanie will sit there. So, but I need to go and I need to drop out. So thank you all very much for joining our session, and again, thank you to all the participating research institutes and the people behind that.